Hi, my name is Ashley, and I'm an incoming freshman at the University of Wisconsin-Madison. So for my project, I did a pulse oximeter. The way this is supposed to work is that you place your finger on the photodiode and that LED, and it's supposed to give you your reading. Here, numbers seen here aren't calibrated yet, but they're supposed to show what it's reading. So when you're moving them, it's sensing the light and should be changing. So the way that it works is that the Arduino is powering the circuit. It takes the ground and voltage and goes into the breadboard. From there, the resistor, which is at positive, goes to where the LED is. The resistor is there so that it doesn't burn the LED. So the LED here is the transmitter and the photodiode is the receiver. They work together to absorb light and be able to get a pulse read. So it creates a current. From there it goes into a transimpedance amplifier, which gets the current that was created here and turns it into voltage. The capacitor is reducing any noise, and the resistor is it's a 1 mega ohm because of the current being so low. And together what this does, the op amp, the resistor, and the capacitor, is that it amplifies the voltage. It goes from being current to voltage. From there it goes into a high-pass filter. The high-pass filter consists of a capacitor and 2 resistors. The capacitor is getting rid of or removing any DC signals or low-frequency signals because we don't need those in order to find a reading. Because before we said how the photodiode and the LED were going to absorb light, but when it's reading your pulse rate, it also catches the light that's from your tissue. So the one from your tissue is really low, and we don't need or we don't want low signal. So what's being done here is that we're only allowing for high frequencies to pass. From there, it goes to AC gain stage, which is similar to what was happening here before. The capacitor, again, is removing any DC bias, and the op amp is amplifying the voltage, which is then going back to the Arduino at A1, and from there we can code it to do as it does. What I enjoyed most about this project was having to figure out how everything works together. Like before, I used to know, like, okay, yeah, I know what a resistor does and what a capacitor does, but here it's like how they work together and how each circuit works, because here there's about 3 different circuits that are working as one giant circuit, so knowing how like each individual circuit works to create the function that it should, I enjoyed that very much. What I found challenging was having to, well, the instructions that were given weren't as clear. Like, there's a website that offers like about this model or how it's supposed to work, but I couldn't really read the schematics too well because they didn't line up to the actual project. So like just trying to figure a way around that and seeing another way how we can make this work using like fundamentals seen there. I think that was quite challenging. For my next milestone, I'm gonna want to try and actually do like the finger cuff so that it looks like a pulse oximeter. So there's where the LED and the photodiode are gonna go, and also calibrating the code because right now it's flashing numbers, but it's not too sure on what those numbers mean. So just calibrating so it could be a more accurate reading.